Hey everyone, in this video we're going to take a look at the CAN signals generated by this setup. So in a previous exercise we've programmed these boards, okay, and basically just to remind you, when you press the blue button here, it sends a CAN message from this board. You see the green light turns on to this board, okay, and the green light has turned on to signify that it's received the message. Okay, so our Nucleo boards are connected. So the Nucleo boards have the CAN or the STM32s on the Nucleo boards. They have CAN controllers, but you need to get some CAN transceivers in order to send the signal. So we've got two boards connected to two transceivers, the CAN high and CAN low. Okay, here's our CAN bus. Okay, they're connected. The two transceivers are connected to each other on the CAN bus. Okay, so we have the setup. What we want to do is we want to take a look at the signals. Now, the scope that I have here, it's one of my ones I have at home here. That's mine. It's an SDS1104X-E, and it has CAN decode capability. So what we're going to do is we're going to start up the segment. All right. So now the baud rate, okay, how many bits per second, because we're using CAN here, it's going to be 125 kilobits per second. So the bit period, 1 over f, is about 8 microseconds. Okay. So we're going to take a look. What are the settings? What do we expect this to be at? So here, you boot up the scope. Just let you know some of my settings here. So anyway, let's start off with the bit rate. What is the horizontal time scale that we should be looking at? So if we have about 8 microseconds per bit, about a 50 microseconds per frame should be enough to be able to see an entire CAN frame within view. The only thing that we want to do, so let's do that first. So let's look at the horizontal scale, and I'm going to make sure that it's around 50 microseconds. Okay, you can go more. You can leave it at 100 if you want, but I know that I'm looking for something, a frame that's about 50 microseconds. The next thing we want to do is, since we're connected to CAN high, okay, what we want to do, if we want to see the waveform here, CAN high is about 3.2 volts above. Okay, so what we want to do, we're going to zoom in on the vertical scale. So what we need to do is we need to drop, okay, our vertical position, put it around minus 3.3 volts here. Let me see if I can zoom in for you. Okay, so that we can see it. Minus 3.3. Okay, and the edge trigger. Okay, so here's the level where we're going to trigger. It's going to be 3.5. Let's say 3.5. I don't know, 3.55. Okay, above our base vertical level. Okay, one thing, the power supplies that I'm using here, I just connected it to the wall. It's kind of noisy. Okay, you can connect to, if you connect to the USB ports of a laptop, for example, the signal will be a lot cleaner. Okay, you can see the noise on the floor. But anyway, we're going to leave it like this just for this example. Okay, so we've got our vertical level. Okay, one thing actually, so we know we're about 3.2, 3.3 volts. The CAN high is going to be above that. So we need to drop our vertical position so we can see, drop this by 3.3 volts. Now, what is our vertical scale? So the vertical scale, what we're going to do, our vertical scale is going to be about 200 millivolts per division. Okay, so we're going to see about a 1 volt drop here. Okay, or a 1 volt jump. Okay, our signal is going to be about 1 volt. It's 1 volt from CAN low to CAN high. I'm going about, my trigger is about 3.3. We're going up to 3.55. It's about half a volt for my trigger. I can go higher if we like. Okay, but anyway, I'm even 3.6. It's fine. Okay. Anyway, so we've got just to show you the settings. Now the probe, if you want to see the probe settings. Okay, let me press this. The probe that I'm using, it's I've set it to a 1x here. Okay, so you want to make sure. Okay, we're on decode. Let me go back here. Let's go back to 1. Okay, so what are the settings that I'm using? I'm using DC coupling. I'm using a full bandwidth limit. Probe at 1x. Nothing on the next page. All right, so I'm going to be able to now. What I'm going to do is I'm going to do a single. Okay, I'm going to do a single capture. Okay, with the settings that I was showing before. So I'm minus 3.2, and my trigger is about 3.5, 3.6 above 3.2 volts. Okay, so if I want to capture the waveform, I'm on the transmit side, connected to the transmit transceiver. Okay, and I'm going to press the blue button. Okay, and that might be a little too high for the trigger. Let me go back to, I got to turn on my waveform, sorry. All right, so again, minus 3.3, 3.5 above that, and we're going to see it here. So I'm going back, I'm going to press the blue button, okay, and you can see that the waveform has been captured. Now, if we're going to decode the signal, actually it already is there. Just want to show you the decode menu. So go into the decode menu, make sure that the CAN protocol, it's hard to show here, CAN protocol is selected. In order to decode properly, the baud rate is 125 kilobits per second so that it knows how to properly decode. All right, so let's go in and take a look. You can actually see that the data, if I move this up and down here, you can see that if you remember from our previous exercise, the ID that we transmitted was hex 100. The DLC, or the data length code, the length, let me go back over here, is 1. Data is hex 02. Go to that floor. And the CRC is just a checksum. Okay, so you can see that the signals that we send, and you can use this in class, we have some scopes in the ESE program that are able to decode CAN. This is just the one that I have, and the process is going to be quite similar. All right, so that's it for today. Just wanted to show you that you can use your scope to debug and figure out what's going on with your STM32 Nucleo boards.